Now guys, the objective of this video is to do a mixed loading case with two-way drainage and beta equals a half. So you can see now in this case, we actually are doing a variable loading and an abrupt change. So this is a mixed case, and we have two-way drainage, so the pore water pressures can escape from the top and from the bottom, the excess pore water pressures. So as always, we're going to make beta equal a half to make our life easier. So we know beta equals CV change in T on top of change in Z squared. So by letting change in T equals 0.25 and change in Z equaling 1 meter, that will allow us to get beta equals a half on 1 squared. This equals a half. Now for this question, it's very important to note that a critical value of time is 6 and 12 years. So we would have to include that in our solution, which means that our increment of time would have to include these values of 6 and 12 months. Now I made my time equal 0.25 of a month, which is, sorry, 0.25 of a year, which is 3 months. So clearly when we go from 3 to 6, it includes it. So we include the 6 and 12 months. That's just an important note that if we're given specific times we need to be looking at which are important, such as 6 and 12 months, we have to make sure that our increment of time will allow us to get those values. Now, as we would, we're going to draw up our table to find the excess pore water pressures. So we have time, the stress, the change in stress, and the layers up to Z equals 4. We would then say have time 0, time 3. Now when I get to time 6 months, I want to split it up into 2. I want to look at a point just before the 6 months starts, which I'm going to denote as 6 minus, and then I also want to look at a point at just after 6 months, which I'm going to denote as 6 plus. So we can then move on to 9, 12, the same thing. We're going to look at a point 12 minus and 12 plus, so a point just before 12 and a point just after 12, and then we'll go up to 15. And the reason we're doing that is because you can see, say at 12, at a point just before 12, the stress is 160, whereas at a point just after 12, it's 100. So that 12 is a very critical value, where just before and just after, you're getting very different values. So we split it up like that. Now we're going to put the stress at all these values. So at time equals 0, we have a 0 stress. At time equals 3, we'd have to find what that stress is. Because this is increasing linearly, this would be 50, because it's halfway between 0 and 6. So this would be 50. At a point just before year 6, it's 100. At a point just after year 6, it shoots up to 160. At 9, it's still 160. Its load is sustained. This is 160. This is 100, and this is 100. We would then find the change in stress from increment from every 0 to 3 months. So this would be 0. We've gone from 0 to 50, so increased by 50. We've gone from 50 to 100, so we've increased by 50. We've gone from 100 to 160. I'm going to draw this in red, plus 60. You're going to see why in a sec. This one from 6 positive to 9 is 0. 0. From 160 to 100, we've decreased by 60. And from 100 to 100, we're having no stress change. So now we can rule this off, and we can draw in columns. Now I'm not going to fill in, what we normally do now is fill in all the boundary conditions. I'm not going to do it just yet because this is going to be important how we split it up like this, and you're going to see why in a sec. But we know that because we're doing two-way drainage, we're going to have 0 excess pore water pressures at the top and bottom, and because we've got no stress at time 0, these are all 0. We move across to our next column, that's 0 and 0. Now we know that because beta equals a half, we're going to be using the formula UB at time 2 is equal to 1/2 of UA of time 1 plus UC of time 1 plus the change in stress. So if we were to work out this value, it would equal 1/2 outside of 0 plus 0. Hopefully you guys will get the hang of what we're doing now. So that will be 0 plus 0, and the change in stress at this point is 50. So we would add on 50, so we would just get an answer of 50. And because all these values are 0, we're just going to be adding on 50 to every single one. So all those are going to become 50. Now at this point it's 0 and 0 due to our boundary conditions. This would be, if I were to do it slowly, 1/2 outside of 0 plus 50. So 0 plus 50 plus the change in stress, which is 50. So we're going to get half of 50 is 25, plus 50 is 75. So this value would be 75, that would be 100, and this would be 75. So now what happens is, at this point, we get an abrupt change from 100 to 160. So all these values are momentarily added on by 60. So just like before when we had an abrupt change at the start, so for the abrupt change, it was at the start, the whole layer felt that stress at the point, right? So the same things here, the whole layer feels the increase of 60. So so we just take this column and we add 60 to it. So that becomes 60, 70 plus 60 is 135. This would be 160, 135, and 60. Now we do what we normally do. So the boundary conditions are 0 and 0 because it's two-way drainage. This value would be 60 plus 160 divided by 2 plus 0, which would be 110. This would be 135, and this would also be 110. This is 0 and 0 due to the boundary conditions. This value would be 0 plus 135 divided 2 plus 0, which would be 67.5. This would be 110, and this would be 67.5. Now, at 12 positive, at a point just after 12, it's reduced from 160 to 100. So we're going to just subtract 60 from every point. So we just take every single value in this column and subtract it by 60. So we get these values here. So this layer, so once again, because there's an abrupt change, at that point in time, at 12 plus, the entire layer feels that stress change. Now we get to 15, this becomes 0 and 0 again because of the boundary conditions, and we can work out that value, which would be minus 60 plus 50 divided 2 plus 0, which would be minus 5. This would be 7.5, and this would be minus 5. Once again, if I would just show you how to work out that value, hopefully you guys will understand by now. It would be minus 60 plus 50. So the UB would equal 1/2 outside of minus 60 plus 50 plus the change in stress, which in our case is 0. So plus 0 would give us an answer of minus 5, which is what we have there. So this is the hardest case you could probably get because it combines the variable loading with abrupt changes. The most important thing to realize, which makes your life very simple for this solution, is to split up the critical point, which has very different values either side, into 6 minus and 6 plus, where you just add on or subtract the abrupt change. And that abrupt change is felt throughout the layer. So that's why I didn't fill in all my boundary conditions to start with, because at some points the boundary conditions is not 0 because the entire layer, every layer in this entire profile will feel that increase or decrease. Anyway guys, hope that helps.